Morning, everyone. I'm K. Vasudha, working as an assistant professor in TKREC. So today I'm going to discuss information security. So the first unit of information security consisting of the following parts. So here the first unit consisting of the introduction to what is the security and what is the need for security and principles of the security, types of security attacks, security services, mechanisms, and model for the network security. In the part 2 of the unit 1, it is consisting of cryptography concepts and techniques. So in the second part, we'll be discussing the introduction of the cryptography, the definition of the cryptography, and what is the plain text, ciphertext, substitution techniques, encryption, decryption, symmetric cryptography, and asymmetric cryptography, and steganography concepts. So let us move to the topics of cryptography here. So before moving to the cryptography concepts, let us discuss first the model for network security. So here why we require the security here is, so nowadays in each and every field, whether it may be a teaching field, medical field, examination, in each and for paying transactions, digital shopping, digital transactions, in every field, there is a need of a computer. There is an involvement of the computing devices and the networks. So whole world is connected to the networks nowadays, and everyone are operating with the networks. So what is a computer network? It is connecting two or more devices is nothing but computer network. So how to provide with the increase of using of the computer networks, there is increasing in the security attacks also. So today we'll be discussing on what is the basic concept of the network security first. So here, so in the model for the network security, if you're seeing here, we'll be having sender, receiver. So the person who is sending any message by using the network is nothing but the sender, and the person who is receiving the message is nothing but the recipient. So here we are saying the two parties, the sender and the receiver, are trying to exchange their messages by using the network. So here the sender is sending the message. So whenever the sender is trying to send the message is to be converted into the secret information. So why there is a requirement of converting it into the secret information here is, so that there is a lot of security attacks. So whenever a person is trying to send the messages which is to the authentic user, the message might be read by the third person and it might cause the security vulnerability. So for that sake, what we need to do is sender, whatever the message, it might be important message he want to send to the recipient. He want to, the message has to be converted to the secret information. So that secret message is sent through the network channel. So that is network channel. So where the opponent, the third party is nothing but the person who is nowhere related to the sending and receiving of the information. A person is sending the information and a person is receiving the information in between the two parties. So any third person, if he is knowingly or unknowingly trying to access the information of the sender, then it is called as security attack. So here security attacks will be caused through when the sender is trying to send the information through the internet or network. So the third party will be available in the network. So they can get hold of the secret information message and they can transform it and they can use that information for their particular use. So at the recipient side, this is a basic model of the network security. At the recipient end, what happens? Whatever the secret message it is sent by the sender, it is again transformed from the secret message to the normal message. That is the plain text, we can say. Secret message, and it is decrypted That is, it is converted back again from the secret message to the normal message, what the actual message sender is trying to send. And will be reached to the recipient. This is a basic model for the network security. So the security will be lacking here in the when the information is sent through the trusted third party. So that is the model for network security. Next, we'll see the cryptography concepts here. So here, the sender and the receiver. So these in the model for network security. So here, who will be the opponent? The opponent may be a hacker, a human being, or it might be a software. Softwares like a vulnerable softwares like a worms, viruses, worms. So access channel will be the network. If you are connecting to the internet, then only there might be the loss of the information. So who will be the opponents for the sending and receiving of the information? They might be the human or the software. And here the main information might be of any data. It might be a process. It might be a software. So these are all computer resources what we have. So the concept of cryptography is, first we'll see the definition of cryptography. Cryptography is nothing but the process of conversion of the plain text to the ciphertext and ciphertext to the plain text. First, we need to know. So that is, if you are taking it cryptography, it is the art of security. So how we are providing security to the data? We are making the plain text. What is plain text here is the actual information what the sender is trying to send to the receiver is nothing but the plain text. So cryptography is achieving the security. That means how can we achieve the security here is we are trying to convert. We are trying to change the information from plain text, that is readable format of the data, to the non-readable format of the data, so that we are providing security to the data. That means here, even if the hacker or the opponent party is trying to access the data, they cannot able to understand the data. That is the process of cryptography. The process of conversion of the readable format of the data to the non-readable format of the data is nothing but the cryptography. So if you are saying this cryptographic system, so here this is the actual plain text message, the message the sender want to send to the receiver. So here the receiver, whatever the readable message we are having, this is a book on network and internet security. This is the message sender want to send to the recipient. Now the cryptographic system, what it will do here is, it will convert this readable format of the data to the non-readable format of the data, so that even if the third party is accessing this data, they cannot able to understand the data. So if you are seeing this, what is this cryptographic system is doing? It is converting the network security, the readable format of the data into the non-readable format of the data. So this process is called as cryptography. And if you are taking cryptanalysis, so the cryptanalysis is the opposite process of cryptography. That is, the conversion from the non-readable format of the data to the readable format of the data is nothing but cryptanalysis. So what we can say here is, cryptography is process of conversion of the readable format of data to non-readable format of the data. And opposite of that is cryptanalysis. Cryptanalysis is nothing but unreadable format of data, what we are trying to do. So here, cryptanalysis, it will be converting back to the readable format of the data. So that is the difference between cryptography and cryptanalysis. And the combination of both this cryptography and cryptanalysis is nothing but cryptology. So what is the process? It is called the combination of cryptography means conversion of readable format of the data to non-readable format of the data is cryptography, and conversion of non-readable format of the data to readable format of the data is cryptanalysis. And when we combine these both technologies together, we call it as cryptology. Now coming, let us discuss what is this plain text and ciphertext. So just now we are discussing what is, when we are discussing the cryptography and cryptanalysis, so readable and non-readable format of the data, we have used the terminologies over there. But here we can use it, we can also use the terminologies called plain text and ciphertext. So what is plain text here is, the readable format of the data, which the user, the sender can understand it. Whenever any user directly, if they are trying to read the information, they can easily understandable format of the data is nothing but plain text. So that the message that can be understood by the sender is nothing but the sender and both the recipient is nothing but the plain text. And here you can see this example of the plain text here. Here we are having, hope you are doing fine. How about meeting at the train station this Friday at 5 p.m. This is an example where we can read this message easily. This is called the plain text message. And when we try, this is plain text. And when we try to convert, and what is ciphertext? Ciphertext is unreadable format of the data. So why we are using the ciphertext, the process itself, the security, how we are achieving here is when we are when we are converting the data into ciphertext. The plain text, we can read the message. The ciphertext is non-readable format of the data. That means by using any coding, that is any cryptographic techniques, if you are converting the plain text into the ciphertext, what we can say that plain text into non-readable format of the data, that is nothing but the ciphertext. So I'm repeating it here again. Plain text means readable format of the data. Ciphertext means non-readable format of the data. So why we are doing this, converting this readable format of the data to non-readable format of the data? To achieve security. That means if the third party, only sender and receiver should understand the message, others, the third party should not understand the message. So to achieve security towards our data, we require the conversion from plain text to the ciphertext. That can be done by using the cryptography concepts. And the process of conversion of plain text to ciphertext is cryptography, and the process of conversion of ciphertext to the plain text is cryptanalysis. And the combination of this both things will be called as cryptology. And we can use, so here to convert from plain text to ciphertext, we are having two methodologies. We can say two substitute techniques we can have to convert from plain text to the ciphertext. So those are nothing but here transforming the plain text into the ciphertext. So here in the brackets, it is specifying it, readable message to non-readable message. So plain text, readable message. Ciphertext, non-readable format of the message. So in order to convert from plain text to ciphertext and ciphertext to plain text, we are having two methodologies or two techniques. So the two methods what we have are substitution techniques and transposition techniques. So here, in order to transform from plain text to the ciphertext, we are having two types of techniques. Those are substitution techniques and transposition techniques. So what is this substitution techniques? Substitution techniques means here, whatever in the place of actual text, we are substituting the different text is nothing but substitution methodologies. So suppose if you are having a message called a secret message called hello. So in the place of hello, if you are writing some other digits or some other alphabets and we are converting it, we are substituting different methods. Means in the place of hello, in the place of H, if you are taking A, in the place of E, if you are using some other alphabet. So that is nothing but substitution technique. In the place of actual message, we are substituting the different alphabets is nothing but the substitution technique. When it comes to the transposition technique, what we are doing, we are not using the other alphabets or other things for substituting the actual message. What we are doing, whatever the message we are having, that the positions of that message, if we are trying to change, then that is said to be transposition. We are not using other alphabets, other things. Hello means hello. Hello is a message if you are trying to send. By using the substitution methods, we can replace hello with any of the alphabets what we can have. But whereas in transposition techniques, we have to compulsory use those hello letters only, but jumbling of the words or the changing of the position or jumbling of the letters also can be done. That is transposition technique. So when we are trying to convert from the plain text to the ciphertext by using the substitution techniques, we are having so many methodologies. So those are Caesar cipher, modified Caesar cipher, monoalphabetic cipher, homophonic substitution cipher, polygram substitution cipher, polyalphabetic substitution cipher, Playfair cipher, and Hill cipher. These are all methodologies which will be used to convert from plain text to cipher text. How it is converting? By using what technique? By using the substitution technique. Now let us see the methods. Caesar cipher. Substitution techniques we'll see, which is Caesar cipher. So what is Caesar cipher here is, it is a special substitution technique. What happens so we can read the cipher, we can read each alphabet in the cipher text message. So what we are doing it here is, by using Caesar cipher, the plain text Guru will become cipher text ZX UX. How? So if you are seeing this example, if you are seeing from A to Z alphabets we have here, and what we are doing, the three positions substitution we are doing in the place of A, D, E, F, G, H, I, J. That means here +3 we have done. If +3 if you have done in the place of A, I am substituting it as D. So this is the methodology of Caesar cipher, where just I am substituting the letters, whatever the alphabets I'm having here. In the place of A, I'm substituting D. So like that, in the place of O, I'm substituting R. So any letters if you are taking, Guru if I'm taking, example Guru if I'm taking, what happens in the place of G, what I'm having, J I'm having. So J will be taken. In the place of U, what I'm having, X. So JX. In the place of R, I'm having U. So JX UX will become the cipher text for what is the plain text here? Guru is the plain text and GX UX is the cipher text. So this is what technique we have used here, Caesar cipher. Just what we have done, we have incremented +3 for each alphabet, and for the place of A, just shuffling of the substituting in the place of A, I'm substituting it as D, like that. From Z, I'm substituting it as Z. This is Caesar cipher. Next, we'll move to the Playfair cipher. So Playfair cipher is also one of the important substitution technique. So it is named after Baron Playfair. So who is this Playfair cipher has been invented by Wheatstone in 1854. So let us we will go with the methodology of how the conversion, how the substitution will be done by using Playfair cipher. So here what we'll do here is every time 5 by 5 matrix will be taken here. We are seeing this example, every time 5 by 5 matrix will be taken. And so example, if you take here, this is the methodology of Playfair cipher. 5 by 5 matrix will be taken as the complete letters will be taken. So first, here we need to convert. If you are saying this, monarchy is the given example keyword. So this is the plain text what we have. Now I want to convert this plain text to the cipher text. So what is the methodology I need to follow? These are the 4 steps we need to follow. First, we need to take 5 by 5 matrix and keyword. So here, for conversion, for conversion from plain text to the cipher text, we require keyword. So here, this is the plain text and keyword. By using this keyword, we can convert from the plain text to the cipher text. So these are the, fill in the letter of keyword first, then rest with the matrix letters of the alphabets, and I and J we are having, if you are taking 5 by 5 matrix. So whatever how many fields we are going to get it here is 25 fields we are going to get. But we have actually what we have, how many letters? We have completely 26 letters. So for that sake, what we need to do, I and J will be clubbed together and kept here. So let us take one example, Playfair example, we'll take it and I'll explain the concept of how this will be taken. So here, let us consider this example and madam. Hello, madam. పౌచ్ మీదేనా తెచ్చాను నేను పిల్లలు అనుకున్నాను నాదేనండి. So let us consider one example for Playfair cipher. So if you are seeing this particular example, so here we are having keyword called harsh, and the what is the plain text to be encrypted here is my name, or else we'll take one simple example of how to convert it. So here we will take keyword as Playfair and plain text as hello there. So here we are taking the keyword as plain text. Keyword is equal to Playfair and plain text. So from the example, we can take plain text as hello there. Hello there. Now, according to the Playfair methodology, what we have to do here is 5 by 5 matrix we need to take. So 5 by 5 matrix if you are taking, what we need to do here is, first initially the keyword letters have to be taken. Keyword letters have to be taken. So I am taking, what are the keyword letters what we have here? We have Playfair first. Now here what I am doing here, P L A Y F A I and R. So I am taking, so whatever the letters of keyword we are having in the 5 by 5 matrix, directly I am placing it here. Directly I am placing it here. Now, what we need to remaining letters. So from A to Z, we need to write the remaining letters here. So A already it is present here. And here it is a redundancy. Playfair means two A's are available. So what I'm doing, I'm removing A here and I'm writing I here and R here. This is Playfair. If I am writing A double times we are having, redundancy should not be there. So what I have removed one A here. Now Playfair is written. Now we need to start from the actual alphabets. So A already we are having. Next B we have. Next C. Next D. And E. Next F. F already it is present in the keyword. So I'm not writing F. G, H, I. I it is present already. I'm not writing I. So wherever I'm writing I need to write it I and J together. This is a concept of Playfair cipher itself. I and J should be together. So G, H, I, J, next K, L, M, N, O, P already present here in the keyword, Q, R, R also it is present, S, T, U, V, W, X, Y already present. Here if you see, L it is already present here. So we should not write L here. So I'm writing directly M, N, O, P, P already present. So Q we need to write it here. Q, R, R already present. So S I have to write. Next it is T, U, V, W, X, and here Y already present. So Z. So what we need to do here is I am converting. Now I have to convert. Now the table is ready. 5 by 5 matrix is ready. Now what I have to do? I have to convert from this plain text to the ciphertext. So after creating this 5 by 5 matrix, what we need to do here is whatever the plain text we are having, this plain text hello there, I need to divide it by two letters each. So here I'm having this hello there is a plain text. Now what I'm doing, I'm just converting the two letters. So if you're having double letters, so what we need to do, I'll just tell you later. So we'll just follow only hi there if I'm using. Hi there is a plain text I'm using. Where there is no redundancy, double letters are not there. If I'm taking that, I'm using hi there. So this is the plain text I'm having. Now what I'm doing here is to this plain text, I need to divide this plain text into two letters. So like this, I have divided. This is the first step of step 1 of plain text. First, we have developed. So whatever these letters are there, this is plain text. Now what we need to do? HA, we are having HA. Then HA, where we are having this HA, we have to see H is here and A is here. So let us go to the rules first. We'll discuss the rules first. So what we need to do here is according to the, now after developing the 5 by 5 matrix, so two letters after defining, what we have to do it here is, if we are having encryption, if we are trying to do, if the both letters, two letters we have taken here, and if both letters are in the same line, or else HI. So here if you are taking this example, hide, this is a plain text what we have, and this is the developed 5 by 5 matrix. Now HI we are having, H is here and I is here. Now it is in the form of rectangle shape. So if we are having this rectangle shape, what we are trying to do it here is, so we need to take, for H, we need to take the element B, and in the clockwise direction, for I, we have to take M. And if we are having the letters, two letters, whatever the two letters we are having within the same column, then what we need to do, next element we need to write. Suppose here DE we have. D we have in the same column means what for D, what element we need to take? For D, next element is O. For E, next element is D. So in this format, we need to take in the column sector. So if you are having in this rectangular format, we need to take clockwise. We need to take in this type, the element in this type. And if it is in the column wise, we need to take in this format. And suppose if the elements, two elements are forming the rectangle shape means the same thing. So clockwise direction H, for H we need to write, so for B we are writing H, and for Z we are writing it as T. For T we are writing it as Z. So in the clockwise direction, we can take the rectangle in this way format, rectangle. So you can see some of the examples. If you are having the rectangle shape in this format, if you are getting, for H, it is taken as B. For T, it is taken as H. So if you are having only the small box of the rectangle here, in this case, we are taking for E, we are taking X. For D, we are taking G. E, we are taking X. In the clockwise direction, E, we are taking X. For G, we are taking it as D. And the same element, we are talking in the same row, if you are having, next element we are taking. Column also, next element we are taking. The same thing will apply for our example now. Same thing for, we can apply for this here. For HA, if you are taking H, so I'm just changing the color of this one. HA, first one HA. We are taking H, then A. If you are taking, both are in same column. So for what we need to do here is, for H, we need to take the next element, that is Q. For HA, we can write for HQ, and for A, it is next element we need to take, it is B. And for IT, next go it for the two elements we have divided, and now what we are doing, we are converting it into the ciphertext. For HA, it is QB. How we got this QB? H and A both are in the same column of 5 by 5 matrix. If they are in the same column, what we need to do? We need to take the next element of that thing. For A, it is B. For H, it is Q. Next, IT. So for IT, I and T, let us see where they are present. So in the table, if you are taking, I and T is present in the rectangular format. So I is here and T is here. Now what we need to take here? For I, we need to write it as D here. So this is the element. This is a complete rectangular it form. The opposite of the rectangle elements, we need to take it here. For T, we need to take N. For I, we need to take T. So here IT, what we'll get it here? T, and for T, what we are getting? For T, it is N. The rectangle box it is forming here is this thing. This rectangle. So for D, for I am taken the opposite of the rectangle shape D, and for T it is N. Next, HE will take H and E. Where is H and E? We need to take, see in this table. H is here. Here we have H already and E. So E, H and E both are in same row. H and E both are in same row. When you are having in the same row, what we need to do? Right side element we need to take. Column means next element, the downside we have to take. If it is the same row, both are having in the same row means what we need to do? We need to take the right element. So for H, it will be K. If you are taking for H, it will be K. And for E, it is G. Okay. Next, R, E will consider. For R and E, where is E? E is here and R is here. So here it is forming this rectangle. So in this small rectangle, what we can do? For R, we need to write it I. For G, we need to write it E. In this example, if you see in this small, for E, we are writing X. That means in the same row letter, for G, we are writing D. So here in this example, what we are doing in this example? For R, I or J. For E, it is G. So for the plain text, hi there, what will be the ciphertext? Finally, what we have found? QB, DN, and KG, and finally I or J, G. We can write I or J. I or J, next G. So this is the final ciphertext for the plain text hi there. So for the playfair technology, we are using 5x5 matrix we need to develop, and we can convert from plain text hi there to the ciphertext. So this is the playfair cipher substitution technique. Thank you.